The concept of the ultimate warship has haunted naval architects for centuries. By the late 1960s, the United States Navy faced a critical strategic decision to build the most massive, powerful, and technologically advanced vessel ever conceived. This was the vision of the CVN-23 nuclear-powered attack carrier, a ship so large it was conceptualized as a floating city, promising unparalleled projection of air power across the globe. It was intended to be the successor to the earlier Nimitz-class design, pushing the boundaries of naval architecture and strategic spending into a new, unprecedented era. The sheer ambition of the CVN-23 project was immense. Its construction would have required the largest dry docks and the greatest concentration of naval engineering expertise in the world, becoming the single most expensive platform ever proposed by the Department of Defense at the time. Before we dive into the catastrophic failure of this naval titan, please take a moment to hit the like button and subscribe to Never Built. We uncover the lost future that the world canceled. We promise you this. Stick with us until the final segment, and you will learn the one specific, chilling strategic analysis that proved the CVN-23 was already obsolete before its keel could even be laid. Here is why this ultimate symbol of naval power was canceled. The first, overwhelming obstacle was the prohibitive cost and overruns. The projected initial cost for the CVN-23 was so high it consumed a disproportionate amount of the Navy's entire shipbuilding budget, creating immediate political opposition. The Navy had to prove the necessity of a massive, single, high-risk asset against the demand for a diversified, numerous fleet. The second, inescapable hurdle was logistical incompatibility. The sheer size of the CVN-23 would have rendered it too large for many major global ports, limiting its operational flexibility and strategic deployment options. The third, fatal flaw was concentrated vulnerability. Concentrating immense capital, nuclear power, and air capability onto one ship created a single, unmissable target, violating the core strategic principle of dispersal. The Navy had to convince Congress that the enormous risk was justified. The entire concept of the CVN-23 was driven by the desire for maximum endurance and speed, features only possible through nuclear propulsion. The ship was planned to carry multiple advanced nuclear reactors, far more powerful than those used in earlier carriers, promising decades of service life without needing to refuel. This unlimited range was the primary strategic selling point, allowing the carrier group to maintain patrol stations globally for extended periods without returning to fixed bases. However, this nuclear advantage came with a crippling, concealed cost: decommissioning. The expense of safely dismantling a massive, multi-reactor nuclear hull after its service life would consume billions of dollars, a liability that was scarcely factored into the initial budgets, leading to massive financial misrepresentation. The Navy was not just building a ship, it was building a future financial black hole. The sheer size of the CVN-23 was the subject of immense architectural scrutiny. The vessel was designed to be significantly longer and wider than the Nimitz class, increasing the flight deck area to accommodate the next generation of massive, heavy fighter and strike aircraft. This increased size was necessary to improve launch and recovery cycles and reduce deck congestion. The larger flight deck also required an immense structural support system, necessitating specialized steel alloys and complex welding techniques, pushing the limits of shipyard capabilities. The vessel's bulk, however, created immediate logistical issues. The Navy relies on a global network of ports and dry docks for maintenance and repair. The CVN-23 would have been incompatible with a significant portion of this global infrastructure, severely limiting where the carrier could be repaired or restocked. The necessary construction of specialized, massive dry docks in strategic locations globally added hundreds of millions to the overall cost, transforming the carrier program into a global infrastructure development project. The carrier air wing intended for the CVN-23 was also a major factor in its design and cost. The ship was conceptualized to carry a larger, heavier, and more complex mix of aircraft, including massive E-2 Hawkeye radar planes and advanced strike fighters. The flight deck required more powerful steam catapults and massive arresting gear systems to manage these heavy aircraft, systems that demanded continuous maintenance and immense power output, adding to the load on the nuclear plant. The ability to launch and recover aircraft faster and in greater numbers was the ship's operational goal. But this complexity meant that the ship's vulnerability to technological obsolescence was high. A single, fundamental flaw in the catapult or arresting gear system could render the entire multi-billion-dollar platform useless. The Navy sought maximum capability but incurred maximum risk. The political battle over the CVN-23 was intense, pitting traditional naval strategists against proponents of cost-effective, decentralized naval power. Powerful figures in Congress, led by advocates for fiscal restraint, questioned the prudence of placing such a large percentage of the nation's air power into a single, high-risk, high-cost hull. The argument centered on the concept of marginal utility. Could the Navy achieve the same level of global air power projection more effectively and safely by building several smaller, cheaper carriers or surface combatants? The cost overruns from previous, smaller nuclear carriers served as a powerful political weapon against the CVN-23. Opponents successfully argued that the immense size and advanced technology were not worth the proportional increase in risk and the consumption of the naval budget. The financial analysis proved that the nation could field a much larger, more diverse, and less vulnerable fleet for the equivalent price of one CVN-23 and its required supporting infrastructure. The project was already collapsing under the weight of its own expense before the final strategic decision was made. The strategic vulnerability of the CVN-23 was perhaps the most compelling argument for its cancellation. Modern naval warfare increasingly emphasized long-range anti-ship cruise missiles and advanced submarine technology. The concentration of power and capital onto one vessel, estimated to cost well over $5 billion per unit, was seen as an unacceptable risk. A single, successful torpedo or missile strike could instantly eliminate the equivalent of an entire Air Force wing and consume billions in taxpayer money. Military strategists argued for dispersal strategy of deploying air power across multiple, smaller, less detectable platforms. The concept of a single, massive floating fortress was a relic of World War II thinking, wholly unsuited for the missile age. The risk of losing the ship and its nuclear reactor in hostile waters created not just a military setback, but an environmental and geopolitical nightmare. This strategic reassessment proved that the pursuit of absolute size had outpaced the realities of modern warfare. The second phase of the CVN-23's failure was defined by the logistical nightmare of operating a vessel of its proposed size, a problem that naval architects had never before encountered. The massive dimensions required to support the extended flight deck and increased aircraft load, dimensions that exceeded previous carriers, created immediate global operational constraints. The sheer beam and draft of the CVN-23 would have rendered it incompatible with a significant portion of the world's major ports, particularly those in the Pacific and in older European theaters. This lack of access meant the carrier would be unable to enter key strategic harbors for resupply, maintenance, or crew leave, severely limiting its operational flexibility and strategic value during a crisis. The Navy relies on its global network of dry docks for essential maintenance and hull repair. Only the largest, most specialized dry docks in the world could accommodate the CVN-23. This created an unacceptable maintenance bottleneck. If the carrier required major underwater repair, it would likely have to travel thousands of miles back to the United States, consuming months of crucial deployment time and placing the ship at risk during transit. The only alternative was the colossal expenditure required to build several new, massive dry docks globally, effectively transforming the carrier project into a global infrastructure development program costing billions more than the hull itself. The political battle over these necessary but astronomically expensive support facilities further eroded congressional support for the entire CVN-23 concept. The proposed nuclear propulsion system for the CVN-23, while offering unlimited range, added another layer of logistical and security complexity. The ship was to house multiple advanced nuclear reactors, making it the most powerful surface vessel ever built. However, operating nuclear reactors demands specialized crew, continuous monitoring, and highly secure maintenance protocols. Any accident, collision, or hostile strike that compromised the reactor containment would result in an environmental and geopolitical disaster, contaminating massive areas of the ocean and potentially triggering an international crisis. The immense risk of placing multiple nuclear plants onto a single, high-value target was seen by many defense analysts as fundamentally unsound, particularly when the nuclear submarines could perform similar deterrent roles with far greater stealth and dispersal. The financial projections for the CVN-23 were constantly undermined by the inevitability of cost overruns. Naval shipbuilding is historically prone to budget escalation, and the unprecedented technology required for the CVN-23 guaranteed these problems would be magnified. The development of new, specialized high-yield steel alloys, the complexity of welding and brazing the massive, heat-stressed hull sections, and the design of the advanced aircraft handling systems all introduce technological unknowns that reliably translate into massive, unbudgeted expenses. Opponents of the project, armed with data from previous carrier construction, argue that the final cost of the CVN-23 would likely exceed its initial projection by 50 to 75%, effectively consuming the budgets reserved for multiple other necessary ship classes, such as destroyers and submarines. This fiscal risk was deemed too high, forcing the Navy to prioritize quantity and dispersal over singular quality. The carrier air wing intended for the CVN-23 was another source of logistical and operational stress. The ship was conceptualized to carry a larger, heavier, and more complex mix of aircraft, including massive E-2 Hawkeye radar planes and advanced strike fighters. This larger air wing required more powerful steam catapults and massive arresting gear systems to manage these heavy aircraft, systems that demanded continuous maintenance and immense power output, adding to the load on the nuclear plant. The flight deck required a complete redesign to improve launch and recovery cycles, maximizing the number of sorties the carrier could generate. This relentless focus on maximum operational tempo meant that the ship's vulnerability to mechanical breakdown and technological obsolescence was high. A single, fundamental flaw in the catapult or arresting gear system could render the entire multi-billion-dollar platform useless, proving that complexity did not always equate to capability. The political battle over the CVN-23 was intense, pitting traditional naval strategists against proponents of cost-effective, decentralized naval power. Powerful figures in Congress, led by advocates for fiscal restraint, questioned the prudence of placing such a large percentage of the nation's air power into a single, high-risk, high-cost hull. The argument centered on the concept of marginal utility. Could the Navy achieve the same level of global air power projection more effectively and safely by building several smaller, cheaper carriers or surface combatants? The cost overruns from previous, smaller nuclear carriers served as a powerful political weapon against the CVN-23. Opponents successfully argued that the immense size and advanced technology were not worth the proportional increase in risk and the consumption of the naval budget. The financial analysis proved that the nation could field a much larger, more diverse, and less vulnerable fleet for the equivalent price of one CVN-23 and its required supporting infrastructure. The project was already collapsing under the weight of its own expense before the final strategic decision was made. The strategic vulnerability of the CVN-23 was perhaps the most compelling argument for its cancellation. Modern naval warfare increasingly emphasized long-range anti-ship cruise missiles and advanced submarine technology. The concentration of power and capital onto one vessel, estimated to cost well over $5 billion per unit, was seen as an unacceptable risk. A single, successful torpedo or missile strike could instantly eliminate the equivalent of an entire Air Force wing and consume billions in taxpayer money. Military strategists argued for dispersal, a strategy of deploying air power across multiple, smaller, less detectable platforms. The concept of a single, massive floating fortress was a relic of World War II thinking, wholly unsuited for the missile age. The risk of losing the ship and its nuclear reactor in hostile waters created not just a military setback, but an environmental and geopolitical nightmare. This strategic reassessment proved that the pursuit of absolute size had outpaced the realities of modern warfare. The third critical phase in the downfall of the CVN-23 was the strategic obsolescence of the maximum battleship concept, a realization driven by the rapid evolution of missile and satellite warfare in the 1970s. The U.S. Navy was forced to confront the fact that concentrating immense financial capital and strategic power into a single, massive hull was a tactic rooted in World War II in Korea, an era when the primary threat to a carrier was another carrier or a submarine with a direct path torpedo. The rise of anti-ship cruise missiles, ASCMs, and highly accurate, long-range targeting systems completely redefined the risk matrix. The CVN-23, despite its nuclear power and planned defensive systems, remained a large, highly visible target. Its sheer size, which was its greatest asset for carrying aircraft, became its most fatal liability in the missile age. Analysts determined that a single, coordinated salvo of advanced Soviet ASCMs, potentially launched from hundreds of miles away by aircraft or submarines that never entered the carrier's defensive perimeter, could overwhelm the ship's defenses. The destruction of one CVN-23 would not just represent a severe military loss, but a massive financial and morale catastrophe, instantly nullifying billions of dollars and years of strategic planning. This risk was deemed unacceptable by the new generation of defense planners who favored dispersal and stealth. The strategic alternative, which gained traction and ultimately secured the cancellation of the CVN-23, was the concept of smaller, more numerous carriers, or, more accurately, the refinement of the existing Nimitz class. The argument was simple. For the price of one CVN-23, the Navy could either build one giant, high-risk target or two slightly smaller, more flexible, and less vulnerable carriers. Two carriers could operate independently, cover a larger area of ocean, and ensure that a single devastating attack could not cripple the nation's entire forward-deployed air power capability. This shift in thinking prioritized redundancy and resilience over singular, maximum power. The financial analysis demonstrated that dispersing the air wings across two platforms reduced the strategic risk exponentially while providing greater operational flexibility across different theaters. The CVN-23's planned reactor complex also presented an insurmountable political obstacle. The ship was conceptualized with advanced, powerful reactors to maintain high speed and power all the new electronic and aircraft handling systems. However, the sheer volume of nuclear waste generated by the CVN-23 over its projected 50-year service life was staggering. The disposal and storage of spent nuclear fuel were politically contentious and financially burdensome issues, costs that were deliberately downplayed in the initial budget proposals. Furthermore, the specialized security required to safeguard the multiple onboard nuclear plants against internal sabotage or external attack in a major harbor or during transit was immense, adding another layer of unbudgeted security costs and complexity. The nuclear liability associated with the CVN-23 was so immense it became a powerful non-military argument for its cancellation. The debate also highlighted the carrier's logistical dependence on its escorts. No carrier, regardless of its size, operates alone. The CVN-23 would require a massive supporting battle group of destroyers, frigates, and submarines for defense, early warning, and supply. The expense of building and maintaining this specialized escort fleet, capable of keeping up with the CVN-23's high nuclear-powered speed, would consume yet another vast slice of the naval budget. Critics argued that the total system cost of the CVN-23 battle group, was strategically inefficient. The money spent on the CVN-23 could instead be used to field multiple, highly effective guided missile cruisers and destroyers, each capable of independently projecting power and providing greater overall fleet coverage and deterrence, leading to a much more flexible global presence. The technological ambition of the CVN-23's aircraft handling systems also contributed to its cancellation. The drive for maximum sortie generation required completely new designs for automated weapons handling, fueling, and maintenance bays. These systems were complex, unproven, and highly susceptible to mechanical failure. A single point of failure in the automated ordnance delivery system, for example, could paralyze the entire aircraft launching capability, rendering the ship a massive, expensive, but ultimately defenseless floating target. The Navy realized that achieving the necessary reliability and battle damage resilience at this scale of complexity was technically infeasible within the projected timeline and budget. The pursuit of marginal gains in sortie rate was not worth the exponential increase in systemic risk and financial cost. The CVN-23 was ultimately defeated by a convergence of fiscal prudence and strategic evolution. The rising costs, combined with the proven vulnerability of large, high-value assets to modern precision weaponry, led defense planners to reject the philosophy of concentrated power. The decision to cancel the CVN-23 marked a definitive turning point in U.S. naval policy, shifting the focus towards optimizing the existing Nimitz design and investing in advanced, dispersed weapon systems that could perform the carrier's functions without the massive, single-point risk. The cancellation was a victory for the proponents of flexibility and resilience, recognizing that in modern warfare, the largest target is often the easiest to destroy. The fourth and final phase of the CVN-23's history is the legacy of its cancellation, a decision that fundamentally solidified the future direction of U.S. naval architecture and procurement. The abandonment of the hypersized carrier concept was immediately followed by comprehensive reevaluation of the entire carrier fleet acquisition strategy, culminating in a critical shift back to optimized iteration rather than massive, costly revolution. The financial lessons learned from the CVN-23's prohibitive projected cost became the bedrock of all subsequent carrier budgeting. The Navy opted instead to continue production of the Nimitz-class carriers, leveraging the benefits of established design, proven operational protocols, and compatible global support infrastructure. This decision allowed the Navy to rapidly field the necessary carrier numbers, maintain established maintenance cycles, and benefit from the economies of scale that the CVN-23's custom, one-off design would have forfeited. The Nimitz class was a strategically sound choice, a platform large enough for all modern air wings, but compatible with existing global dry docks and far less prone to the catastrophic cost overruns inherent in the CVN-23's completely new technologies. The cancellation effectively ensured that the Nimitz design and its subsequent Ford-class evolution would define American naval power for the next century, proving that stability and standardization often provide greater strategic value than absolute, costly innovation. The strategic debate surrounding the CVN-23 permanently altered the way the Navy viewed target vulnerability. The realization that modern missile technology had turned massive, singular assets into unacceptable risks prompted massive investment in layered defense systems and electronic warfare capabilities. The money saved by canceling the CVN-23 was partially redirected into developing sophisticated electronic countermeasures, advanced anti-missile interceptors, and improved submarine detection technology. The focus shifted from making the carrier hull impenetrable to making the entire carrier battle group invisible and defensively overwhelming. This strategic pivot acknowledged that the CVN-23, by its sheer size, was already too visible to survive the modern battlefield, validating the decision to pursue distributed air defense rather than concentrated offensive power. The CVN-23 also served as a crucial, expensive lesson in system complexity and reliability. The requirement for new, advanced automated handling systems and novel reactor technologies introduced excessive risk. The Navy concluded that complexity exponentially increases the chances of mechanical failure and prolongs repair times, both of which are unacceptable for a forward-deployed strategic asset. The shift back to the more familiar technologies of the Nimitz class reflected a return to the principle that simplicity and robustness are paramount in a hostile naval environment. The theoretical gains in sortie generation offered by the CVN-23's automated systems were not worth the proportional increase in unreliability and the financial burden of developing untested, high-risk components. The CVN-23's failure proved that naval technology must be reliable first and revolutionary second. Furthermore, the cancellation had significant political and industrial consequences. It signaled to the entire shipbuilding industry that the era of unlimited defense spending on singular, massive weapons platforms was over. Shipyards that had anticipated the multi-billion-dollar construction contract for the CVN-23 had to rapidly adjust their long-term planning. The intense congressional scrutiny generated by the CVN-23's projected costs established a precedent for rigorous financial accountability and mandatory third-party cost estimation for all future megaprojects. This shift, driven by the financial absurdity of the CVN-23, ultimately led to more transparent and fiscally responsible defense procurement processes, preventing future single-platform concepts from disproportionately consuming the entire defense budget. The concept's legacy also lies in the enduring debate over naval power projection. While the CVN-23 failed, the necessity of large deck carriers was never fully dismissed. The debate forced the Navy to clearly articulate the unique strategic value of carriers, their ability to deploy air power independently of politically unstable overseas bases. The failure of the CVN-23 refined this argument, channeling the immense resources into platforms that could achieve this power projection without the massive vulnerability. The resulting Ford-class carriers, while massive, reflect the lessons of the CVN-23. They maintain the nuclear propulsion and large flight deck, but incorporate lessons on automation and vulnerability reduction without attempting the kind of radical, budget-busting redesign that doomed the CVN-23. The CVN-23 was a conceptual extreme that defined the optimal limit. The CVN-23 remains a magnificent conceptual monument to the ambition of the Cold War Navy. It was a project defeated by the convergence of economic reality, strategic vulnerability to modern missile warfare, and the immutable laws of complex system reliability. The Navy's ultimate decision was not about technological impossibility, but about strategic sanity. They recognized that a single, massive, multi-billion-dollar ship was an outdated concept in an age defined by precision, dispersal, and budget restraint. The ship was simply too big, too expensive, and too visible to be a viable weapon in the modern era. The CVN-23 was the culmination of the battleship mentality in the age of missiles, a conceptual extreme that was ultimately proven obsolete. The final question remains: the CVN-23 was too vulnerable to long-range missiles. Today, modern aircraft carriers are investing heavily in railguns and directed energy weapons for defense. Do you believe these advanced defense systems will eventually negate the vulnerability argument? Or is the concentration of multi-billion-dollar capital into a single naval hull still an unforgivable strategic risk in modern warfare? Join the discussion below and tell us which modern naval defense system would have been essential for the CVN-23 to survive. If you enjoyed this professional deep dive into the abandoned engineering of the CVN-23 Supercarrier, like this video and subscribe to the channel for more stories about the incredible projects that were never built.